Welcome to Math 1314, Section 3.2 on polynomial functions. Polynomial functions includes a lot of functions that we've already seen. For example, f of x equals a number, our constant functions. F of x equals mx plus b, all the linear functions. F of x is ax squared plus bx plus c, the quadratic functions we just saw. And even 7x to the fifth minus 9x squared plus 11x plus 3. So essentially nice powers of x. By nice powers, I mean no negative exponents and no fractional exponents. So the most general case, don't let this bother you, just says it could be up to some power and then count all the way down to x squared, x, and just a number. This is the most general polynomial functions. So all of these are polynomial functions. Their domain is everything. You can put in any number you like into a polynomial function and it will generate a real number output. The graph of the polynomial functions has no breaks in it, there are no jumps, there are no sharp corners. It's a nice, smooth, curvy looking function. Now the focus we want to look at is if the power of x is an even number, such as x squared, x to the fourth, x to the sixth, x to the eighth, and it's just x to an even power, nothing else, then essentially it looks like a parabola, or x squared. And that parabola can either look up or look down depending on the lead coefficient. So whenever you have a polynomial and it just is x to an even power, it essentially looks like a quadratic function. If you have x to an odd power, x cubed, x to the fifth, x to the seventh, it essentially looks like x cubed. And x cubed can be normal looking if the lead coefficient is bigger than 0, or it can be flipped over if the lead coefficient is less than 0. So what we're interested in is building on that basic idea. And that is, we want to look at what's called the end behavior on the polynomial functions. And by end behavior, I'm looking at the far left and the far right. What happens on those two places? And this end behavior is basically from the dominant term, or the term with the largest exponent. What do I mean by all that? Okay, so here's f of x is 5x to the sixth minus 3x plus 4. The highest exponent in there is 5x to the sixth. Well, x to the sixth is an even power, and the dominant, number in the front is 5, and that's positive. So imagine x to the sixth. The two ends of it are up. Whereas if we had g of x is minus 2x to the fifth plus 6x squared minus 9, the highest exponent is x to the fifth. So this is the term that's going to dominate the far left and the far right behavior. Well, it's x to an odd power. The lead coefficient is negative, so it essentially looks like a flipped over x cubed, where the left side is up and the right side is down. So again, this end behavior depends upon the term that has the largest exponent. Alright, so how does this work in the homework? Alright, we have the end behavior of minus 3x to the fourth minus 6x squared minus 2x plus 9. Alright, so the behavior here is dominated by this minus 3x to the fourth. Alright, so it looks like an x squared that is flipped over. That means that both sides are going to be down. Now in terms of the notation, if I head to the left forever in terms of the inputs, then I'm looking at the end is going down, or it's going to minus infinity. If we go to the right side forever, that's heading this way, I'm looking at the end and it's also going down. And so f of x is approaching or going to minus infinity. So these arrows just indicate a direction we are heading in. If you look at question 2 here, we have 18x to the 7th and some more terms. So the dominant part of this is 18x to the 7th. Alright, so lead coefficient is positive, so it's normal looking. It's x to an odd power, so it's going to look like a normal x cubed, where the left side is down and the right side is up. So as we head to the left forever, the output is going toward minus infinity. And here, if we head to the right forever, we're going up forever, and so k of x is going to positive infinity. Alright, so far so good. So we're looking at the dominant behavior on the far left and the far right. In question 3, alright, we need to figure out here what is the dominant behavior. Alright, so let's take a look at this. We've got a minus 5, so I'm looking for the dominant part. And to do that, alright, I see a minus 5. From this piece I see an x. Here I see a 2x and it's squared. So you can think of that as a 4x squared. From this part I see an x to the fourth. Alright, so I'm just taking the largest powers. I don't need to multiply the whole thing out. I just am trying to figure out what would the highest term look like. So, well, what is that? Well, minus 5 times 4 would be a minus 20. And now how many x's do we have? 1, 2, 3, and 4 more, so x to the 7th. Alright, so the dominant behavior is going to be like a flipped over x cubed. Alright, well, let's see. What did a flipped over x cubed look like? It looked like this, where the left side is up and the right side is down. So, as I head this way forever, the graph is going up. Alright, so that's going to infinity. And now as I head to the right forever, it's going down forever, and I get minus infinity. Alright, not too bad. Now what about this one? This one is a little more complicated. Let's see. Again, I don't have to multiply the whole thing out. I just need to figure out the important pieces. I have a minus 6x to the fourth. Got that. Now this looks a little confusing because see how it's backwards compared to x plus 2 and all the rest of this? This is backwards. So it's important I keep this minus here. This is minus x cubed. And then from the last part I have a 3x. So let's see. I've got a minus 6 and a 3. Got that piece. I've got an x to the fourth. Now what about this? Minus x cubed is minus x times minus x times minus x. Well, it's an x cubed because I've got 3 of them. But I've got minus 1 times minus 1 times minus 1, which is a minus 1, and the x on the end. Alright, so when everything settles, I have a minus 18 x to the 8th. So normally on x to the 8th, both sides would be up. Let's see, make sure we didn't miss something here. I got a minus 6 times 3. That is a minus 18, but oh, we lost this minus 1. So it is a plus 18 and both sides are up. So if both sides are up, as I go to the left forever, this is going to infinity. And as I go to the right forever, it's going up, and that's plus infinity. All right, question 5. Find the zeros of the function and state the multiplicities. What about this zeros business? Well, the zeros are what values of x make it 0. Well, let's see. From this piece, I've got the x squared. Well, that's x is 0. From this piece, I've got x plus 1 is 0, so x is minus 1. And from this piece, I've got x plus 2 is 0, or x is minus 2. So we've got 3 zeros. Now what about their multiplicity, this word on the end? Well, that's just the exponent on that x. So the 0 came from the x squared term. Its multiplicity is 2. This term gave me the minus 1, but the power on the x is just 1. The minus 2 came from this term. The exponent on it is 4, and so that's its multiplicity. All right, let's see, question 6. We are given minus 1/6 x to the 6th minus 3. All right, so what's the dominant part? The dominant part is this x to the 6th, and it's flipped over. All right, so it's going to look flipped over. The minus 3 on the end. Well, we saw when we were looking at shifting functions around, adding or subtracting on the end moved us up or down. And in this case, it's moved down by 3. All right, so well, which one would that be? I'm looking for a flipped over parabola moved down by 3. No on A, it's not flipped. No on B, that didn't move down, it moved right. C and D look like x to odd power, so no, not that. And again, F looks like an odd flipped over. And this one looks good. This one is shifted down. Notice it's shifted down by 3. And so it is that. In this first part, identify the important term. Well, that's x to the 6th. And now what happened to our x to the sixth? Well, we already talked about that when it's minus, it got flipped over. The 1/6 vertically shrinks it. And then the -3 on the end moves it down. Now, to think about this shrinking and stretching business, let's come over here to the side for a moment and take, for example, x squared. Here's x squared. And let's say I put in 1. Well, if I put in 1, 1 squared is 1. Well, what about if we were looking at 2x squared? Well, 2x squared is going to make it higher, right? A 2x squared. Because here at 1, 1 squared is 1 times 2 would make this now up at 2. So I'm trying to show you that if it's a 1 in the front, it looks normal. 2 stretches the graph upward. And so you can see if we looked at 1/2 x squared, it would shrink it down even lower. And so this 1/6 is a vertically shrink. Okay. C just says match the graph. We already took care of that, so not sure why they asked it again. All right, what about question 7 here? Looking at question 7, all right, I've got -1/2 x minus 4 to the 4th. All right, well, the dominant part is going to be -1/2 x to the 4th. So it is a flipped over x to an even power. There's nothing on the end, so there's no up or down. Looking here inside, this is a left or right. X minus 4 is 0, so I get x is 4. So it should look like a flipped over x squared that's been shifted to the right by 4. All right, so let's take a look. And what's all happened to this guy? All right, so we did get shifted to the right by 4. The 1/2 is not 1, so it does shrink this guy. All right, the negative means that it flips it. It did reflect it. All right, what about the picture? That is flipped over, but that went down. That's not it. Let's see, this is flipped over. It did move over by 4, so that's a yes. C and D, no, those are x to odd powers. And let's see, this one got shifted to the right. I mean, that's correct, but it's not flipped over. All right, question 8 here. What about this guy? Let's see. Well, the important part is it's x cubed. Lead part is a positive number, so it's essentially going to look like an x cubed normally. The -3 on the end, we go down by 3. The x plus 2 is a left or right. All right, well, let's see. It's a left because when I set it equal to 0, I get -2. So I need to find a graph that's been moved left by 2 and down by 3 and looks like x cubed. Let's see, over 2, down 3. That's our function. C and D are flipped over x even. This one got flipped over and shifted, but ours was not that. And again, this is x to an even, and we had x to an odd. The parent was x cubed, got that. What happened to it? We did get shifted left. Now this case, it stretches it. It makes it taller because there's a 2 in the front, and 2 stretches it more than just a normal 1. If it's a fraction, then it's going to shrink it. Then match the graph. We already talked about that. Okay, so now what about question 9? Question 9 is a little bit tricky, and so we have to be somewhat cautious here. They're messing with us. Yes, it is an x to the 5th, but look inside here. This looks rather strange. Well, let's see, minus x minus 3. I could factor a minus 1 out of that, right? Minus 1 times x is minus x. Minus 1 times 3 is the minus 3. Now, when you have a product of items raised to a power, you can split the product and take that exponent on each part. So let's see, that's minus 1 to the 5th. Well, minus 1 to the 5th is minus 1. And I've got the x plus 3 to the 5th. So this thing really looks like minus 1 x plus 3 to the 5th minus 1. Which means now we know what it looks like. It's flipped over. It looks like x to an odd power. We went down by 1, and the inside part says we went left by 3. So I'm looking for a flipped over x to an odd that's moved left and down. Well, let's see. No, that's x even, not a. B. It is flipped, but this one went left and up. Nope, we need to go left and down. All right. Nope, x to an even. Well, this one did move, but it's not flipped. X even, no. Okay, what about F here? Let's see, we did go left by 3, down by 1. That looks good. And it is a flipped over x to an odd power. And that was x to the 5th. Alright, so what happened to our friend here? Well, let's see. There's no stretching or shrinking because it's a 1. It did go down by 1. It did get shifted left by 3. And it did get reflected about the x-axis because of the minus 1 on the front. Match the graph. We already did that. And so that concludes our look at polynomial functions. Very nice functions, large class that includes lots of different things.